Hi, this is the fourth part of 2025 Neet chemistry question paper discussion. And here we start with the 66th question. 66th question. It is from amine, and the question is regarding the order of the basic strengths. Okay. In the textbook, there is a chart given suggesting the order of basic strengths of several amines. We can learn them all together without much difficulty by applying some tricks. I will explain that. First, we will answer the question. The correct order of basic strength. See, there are same set of compounds are given in different orders, and most of us know. See, the correct order among them will be diethylamine or N-ethylethanamine, IUPAC's name, diethylamine or N-ethylethanamine, then ethylamine, then methyl aniline, N-methyl aniline, then aniline. That is the correct order for the bases given in the question paper. Option is 4. Now, those who are not yet confirmed the order, made by heart the order, there are some tricks which will help you. Most of us know the first points. For if it is ethyl group on nitrogen, that is ethylamines, we know that when there are two ethyl group, imagine that we are substituting alkyl groups on ammonia that way. So when there are two hydrogens substituted by ethyl group, that will be the strongest. Then the case is 3 ethyl group. 3 ethyl group. Ethylamines, when there are two ethyl groups, it means N and diethylamine or N-ethyl ethanamine is the strongest. Then 3 groups. All the 3 hydrogens are replaced by ethyl group comes then only. Then comes 1 ethyl means ethanamine. This is N diethyl ethanamine. N-ethyl ethanamine, N diethyl ethanamine, and ammonia. 0 stands for no substitution, so 0 stands for ammonia. So that is regarding ethyl group substitution. All of us know that. If it is methyl instead of ethyl, we know the only difference is that first and last are the same, 2 0 2 0. But in between, first comes 1, then comes 3. Here 3 greater than 1, here 1 greater than 3. You know that. That is N-methyl methanamine first, then methanamine, then N-dimethyl methanamine, that is trimethylamine, then ammonia. Okay. Suppose they ask in a mixed manner, this and this together, ethyl versus methyl, because that chart gives all such things. So they can be asked in a mixed manner to trouble us. To elevate the standard of the question, they may mix them. In that case, if ethyl and methyl alone are mixed, I am telling the method, please make by heart this word. E-memo. E stands for E-memo. See, in Malayalam, E means this. So, this memo. In Malayalam, you can call it E-memo. Okay. And then regular spelling of memo is having only one M here. But here, as the stressing, it is E-memo. So, it goes along with the pronunciation. E-memo. Remember that word. Then, there are 3 E's in this word and 3 M's are in the word. Okay? There are 3 E, but not consecutively. 3 M also, that is also not consecutively in this word. Now, this is the order here. For E, it is 2, 3, 1. No. You write subscript 2, 3, and 1 for E in the same order. Got that? Now write for M. 2, 1, 3 is the order. So first M 2, second M 1, third M 3. Now you got a mixed order. What does this presentation now means? This is the decreasing order of strength. Diethylamine is the strongest. Triethylamine comes next. Dimethylamine comes next. Ethylamine comes next. Methylamine comes still next. And trimethylamine, the last, finally followed by ammonia. So you got the mixed order. You got the idea. You remember the word E memo and write the decreasing order of 2, 3, 1 for E. Then write the decreasing order of M 2, 1, 3. Now you got the mixed order. 2 ethyl group, 3 ethyl group, 2 methyl group, 1 ethyl group, 1 methyl group, 3 methyl group. That will be the mixed order if you verify the pKb values in that chart. Okay. Ethyl, we have described everything. Now we have to include aromatic and one aralkyl. One aralkyl is there, that is benzylamine. Benzylamine. Please remember, in this list, benzylamine comes just before ammonia. Just before 0. I haven't put any symbol for that. Here after we can merge this further list with this very easily. The only thing you have to remember, this benzylamine comes just before ammonia. Because for ammonia pKb is 4.75. For benzylamine it is 4.7. You don't have to make by heart all the values. This trick you have to make by heart. So benzylamine comes just after methylamine. Benzylamine comes just after methylamine followed by ammonia. Now the three remaining in the chart are aniline, N-methylanilin, N and dimethylanilin. Aniline, N-methylanilin, N and dimethylanilin. Here you can remember them in the order this way. Which way? Here, in substituting hydrogen with the more and more methyl group just helps to increase the basic strength. No negative impact there. No negative steric impact there. Okay. So, including more methyl group enhances the basic strength in the order. So, what happens? There, after ammonia, all this comes. After ammonia, all this comes. That also you have to remember. Benzylamine is inserted here, whereas the remaining are added after 0. This O. How? N dimethyl comes first. N-methyl comes then. Free aniline comes last. Okay? Here, adding methyl group has only advantage regarding the basic strength. In that case, just after ammonia, what comes is N dimethylanilin. Then comes N-methylanilin. Okay? N-methylanilin. And finally comes aniline. So, what is the advantage now? You know the whole chart in the order by some technique other than simply making by heart. It is not making by heart. It is applying a technique which is easier to recollect. Okay? So, first remember E memo. Then insert benzylamine in between. Then add N and dimethylanilin, N-methylanilin, and finally aniline. So, we can reproduce, we can answer any question with any twisted orders. We can correct them. We can get any set taken from that list. You can answer them. Hope you understood that. So, here the answer is 4. Okay. We'll proceed. Okay. Now the 67th question, it is from qualitative theory of the qualitative analysis, theory of the practicals. Okay. The question is, you are given a set of cation and you have to identify in which group they get precipitated. Okay. The first one, in the list, the first one, CO2 plus, cobalt ion. If you remember, cobalt ion is precipitated in the fourth group where the reagent, if you remember, ammonium chloride, ammonium hydroxide, then pass H2S. Means H2S is passed in the basic medium. Hydrogen sulfide is passed in the basic medium. Since hydrogen sulfide is a weak acid, in the weak basic medium, it gets it shows a greater tendency to ionize more and to produce more comparatively more sulfide ions than in the acidic medium. I repeat, H2 is itself being a weak acid in a basic medium, weak base of course, weak basic medium, it tend to ionize more, producing somewhat more sulfide ion, and so cobalt get precipitated as nearly black cobalt sulfide there. Okay, so cobalt sulfide is precipitated in the fourth group. Even though H2S is passed in the second group also, it doesn't get precipitated there because there H2S is passed in the acidic medium. In acidic medium, H2S will not ionize due to common ion effect, or the ionization is extremely feeble. So sulfide ion concentration will be extremely low. So only those sulfide like PBS with extreme low solubility will precipitate there. Cobalt, manganese, etc. cannot precipitate because they have somewhat slightly high solubility product. So they wait for another occasion where medium turns basic, which happens in the fourth group only, and so they get precipitated in the fourth group only. Okay, nickel, etc. So cobalt is precipitated in fourth group. Then magnesium ion. We know that magnesium ion gets precipitated in sixth group. See, towards sixth group generally salts have better solubility. That's why highly soluble compounds are precipitated towards the end of the group separation. So magnesium compounds are generally more soluble. Magnesium, sodium, potassium compounds are more soluble. That's why they come towards the end of the analysis. What is the reagent for precipitation of magnesium? Here also ammonium chloride, ammonium hydroxide, then sodium dihydrogen phosphate, NaH2PO4 is added. Then magnesium ion in the medium precipitated as magnesium ammonium phosphate. Okay, white precipitate. So magnesium ion precipitate in the sixth group. Now comes lead ion, Pb2+. We know that Pb2+ precipitated in first group itself because Pb we are here there the reagent is HCl, no? So PbCl2 being of low solubility, so that the ionic product exceeds the solubility product of PbCl2. Since solubility product is very low and we are adding HCl, square bracket Pb2+ into square bracket Cl minus square exceeds the permitted solubility product of PbCl2. So that is precipitated. And aluminium ion get precipitated in third group as its hydroxide, isn't it? The reagent is again ammonium chloride, ammonium hydroxide, ammonium chloride, ammonium hydroxide. Then aluminium, white gelatinous precipitate of aluminum hydroxide is precipitated. Okay, you have to remember in the group analysis, only the first and second group ions are precipitated in acidic medium. Third, fourth, fifth and sixth are in basic medium. Okay. So our answer for among the given option, if you verify, you will find 3 is the correct answer there. Okay. The next question. It is regarding the acid strength of H3PO4. You can say it comes from either chemical equilibrium or from P block elements. It can be grouped in either of these. See, regarding phosphoric acid, they have given certain statements and you have to choose which of them are correct. Okay. The first is, see, H3PO4. They have also mentioned one more thing. The corresponding ionization constants for first stage, second stage and third stage of H3PO4, I haven't written those explanations on the board, are Ka1, Ka2 and Ka3. the first stage ionization constant, second stage ionization constant, and third stage ionization constants are respectively them. Then the first statement A, log K is equal to log Ka1 plus log Ka2 plus log Ka3. Is that statement correct? Yes. Why? Because we know that the net constant K is equal to Ka1 into Ka2 into Ka3. The product, the net equilibrium constant is the product of equilibrium constants of all the stages together. This is correct. So upon taking logarithm, this become log K is equal to log Ka1 plus log Ka2 plus log Ka3 from the rule of logarithm. So first statement is correct. What about the second statement? It states that H3PO4 acid is stronger than H2PO4 minus and HPO4 2 minus. They mean that the first stage of ionization of acid is easier. That's why H3PO4 is stronger than. Second stage ionization, it is another acid. From H3PO4, it is H2PO4 minus. An anion is acting as an acid. And an anion's tendency to release a proton will be less than the tendency of a neutral molecule to release a proton. Naturally, as acid, H3PO4 will be stronger than H2PO4 minus. And upon the third ionization, see the HPO4, once it ionizes, it becomes HPO4 2 minus. The third stage ionization is still difficult because an H plus, a positive charge, has to move away from a doubly negative charged anion, which is HPO4 2 minus. Once it moves, it becomes triply negative charge, PO4 3 minus. From that, H plus has to move away. That is still more difficult now. The first stage ionization is the easiest, second is more difficult, third is still more difficult. Correspondingly, the acid strength will decrease. So this statement is very much correct. H3PO4 acid is stronger than H2PO4 minus and HPO4 2 minus. An easy guess there. You see, it is not guess. We are sure about that. Third, that statement C is this itself. So it is also correct. So A is correct, B is correct, C is correct. What about D? Ka1, Ka3 plus Ka2. See, average values works only when the changes are uniform. Here the changes are not uniform. If at all it were uniform, it would have been Ka2, Ka1 plus Ka3 by 2. So even such a misunderstanding cannot be there because it is not a linear change in the acid strength. Okay, so in all the way this is wrong. What I mean? So D is wrong. So only first, second and third are correct, means A, B and C are correct. Such an option is given as option 1 there. So for this question, A, B, C correct means option 1 is the correct answer. Okay. The next question, it is from classification of elements and periodic table. 69 is the question number. And here they have given a set of statements and you have to identify which of them are correct. Such questions are always more risky because only if you know more than one idea, you can answer it. So such questions involving multi-information, such problems are involve more risk always. Okay. The first statement, unlike gallium, cesium has a low melting point. It's a cheating question. Unlike gallium, cesium has a low melting point, we know. But unlike gallium, no. Gallium is also having low melting point. So they cheat, isn't it? So it's a wrong statement. Second one. On Pauling scale, electronegativities of nitrogen and chlorine are not the same. We know that in Pauling scale, both nitrogen and chlorine having the same electronegativity 3. So to say not the same is wrong. So second statement is also incorrect. Third, C. AR K plus, Cl minus, Ca2 plus, S2 minus are all isoelectronic. Is that correct? See, I have written that. See, I keep things written because we waste less time on writing and spend more time on explanation. That's why I already keep them written. See, P3 minus. These elements are nearby elements. Phosphorus, sulfur, chlorine, argon, potassium, calcium. These are sequential elements in the periodic table. The middle element argon is having 18 electrons. 18th element it is, so 18 electrons. So the previous elements, chlorine will have 17, sulfur will have 16, phosphorus will have 15. The preceding elements, potassium will be having 19 and calcium will be having 20 electrons, isn't it? So to make them isoelectronic, you add 3 electrons to phosphorus, 2 electrons to sulfur, 1 electron to chlorine, no electron to argon, 1 electron is removed from potassium and 2 electrons are removed from calcium, so that all these elements all these atoms become isoelectronic with a 18 electron. So this statement is correct. So far A is wrong, B is wrong, C is correct. Next, D. First ionization element, silicon greater than, aluminum greater than, magnesium greater than Na. The order of these elements in the periodic table, Na, Mg, Al, Si. Sodium, magnesium, aluminum, silicon, isn't it? Across the period, ionization energy actually increase across the period. So we may expect from sodium to magnesium to aluminum to silicon, ionization energy increase regularly as shown here. But there is some exceptions happen always. Magnesium, it is having 3s2 electronic configuration. 3s2 electronic configuration, no? So in the case of magnesium, electron is removed from electron is removed from a pair. Electron is removed from a pair which involve more energy. Whereas in the case of aluminum, electron is removed from it is an unpaired electron from p orbital, isn't it? So it will be comparatively easier. For this reason, this regular order is not observed in the ionization there. The order is actually silicon, then comes magnesium, then comes aluminum, finally sodium, decreasing order. So the specialty here is that aluminum is having less or magnesium is having more ionization energy, which is due to this reason. Okay, removing electron from a pair is difficult than removing a single electron, for that reason. So first ionization energy's given order is wrong. First, you got that. The correct order is silicon, magnesium, aluminum, sodium, decreasing order. So this is again wrong. Next step, E, atomic radius of cesium is greater than lithium and rubidium. Yeah, lithium, sodium, potassium, rubidium, cesium, francium. So only francium is might be having higher ionization, atomic radius probably. Okay, so lithium and rubidium having lower atomic radius than cesium is correct. So E is correct. So what is our conclusion? C and E are correct. The remaining 3 are wrong, no? So 3 is among the given option, 3 is the correct answer. 3 is the answer to be chosen there. Okay. The next question, it's 70. Question number 70. This is from P block elements. See here the question, statement based type, statement 1 and 2 type. The first statement, like nitrogen forms ammonia, arsenic form argine. That's the first statement. We have to verify whether it is correct or not. Nitrogen forms ammonia means I'm forming NH3. Arsenic form argine. Arsenic AR. Arsenic is AS. AS. Does it form ASH3 and is it arsine? There are two things we must know. Is arsine ASH3? Yes, it is correct. Arsenic is ASH3. And is it formed? Yeah, it is true. So that statement is true. Like N forms ammonia, arsenic As form ASH3. That's a correct statement. Antimony cannot form antimony pentoxide. Antimony pentoxide is Sb2O3, O5. As per our, yeah, it is correct. Our text say Sb2O5 is stable. So here this statement is correct. Here it is formed, it's a cannot form. So it is formed. So it is incorrect. So statement 1 is correct. Statement 2 is incorrect. Fourth option in the question paper. Okay, 4 is the answer here. Question number 71. It is from the chapter solutions of second year. And here the question, you are given 4 solutions and you have to say which is having the highest boiling point. We know that greater the ionic or particle concentration or solute concentration, solute particle concentration, higher will be the boiling point. Here the solutions they have provided us with is 0.01 molar glucose, C6H12C6. It can be glucose or fructose. In either case they are non-electrolytes. So the particle concentration will be the same, 0.15 molar, no change. Second case, urea. Urea is also a non-electrolyte or non-ionic electrolyte. It is non-ionic, this is also non-ionic. So here also there will not be any change in concentration. But KNO3, that's a electrolyte, ionic electrolyte, which ionizes a strong electrolyte. So each molecule will furnish 2 ions, one K plus and one NO3 minus. So we expect the particle concentration to be doubled. 0.01 molar will produce 0.02 molar ions. And finally we have 0.01 molar K2SO4, Na2SO4. Here the particle concentration will be tripled. Why? 2 cation and 1 anion will be formed from each molecule. So particle concentration will be tripled, 0.03 molar. Okay. Yeah. So we know greater the particle concentration, higher the elevation in boiling point, higher the boiling point. Higher the elevation in boiling point, higher the boiling point. So doubtless it will be 4 with the highest boiling point here, isn't it? So simple, comparatively simple question. Okay. Next question, 72nd question. See, it can be said to be from chapter amine because both are related to ammonium, diazonium salt. The first question, the first statement based problem. First statement, we have to check whether both statements are correct or not, etc. Statement 1, benzene diazonium salt is prepared by reaction of aniline with nitrous acid at 273 to 278 Kelvin. That we know, it is correct, isn't it? I have presented it as an equation here. The question is given as a statement. Here I have presented it as an equation and we know that statement is correct. Treat aniline with a nitrous acid, 273 to 278 Kelvin, giving you diazonium salt. The very first statement also says it decomposes easily in the dry state. Yeah, we know that. So diazonium chloride, benzene diazonium chloride is thermally unstable. Only at a low temperature it exists, no? So that statement is correct completely. Statement 2, insertion of iodine into the benzene ring is difficult and hence iodobenzene is prepared through reaction of benzene diazonium salt with the Ki. It's a correct statement. You know that benzene upon treating with the iodine, if at all when iodobenzene is formed, the side product is HI and HI is a strong reducing agent. It drives back the equation back to benzene and iodine. So direct iodination of benzene is rather difficult. So easier way is what? You produce you prepare disonium chloride and treat it with the Ki. Then you get a iodobenzene by substitution of the disonium group. So second statement is also correct. So regarding question number 72, both the statements are correct. Statement 1 and statement 2 are correct. Means option 2 is your answer here. Option 2. Question number 72, answer is statement option 2. The next question, question number 73, it is from aldehyde ketone. Here what is the reaction? It is the conversion of an ester to an aldehyde. See, methyl benzoate is converted to benzaldehyde, and you are asked to identify the reagent which can be used here. The given options are hydrogen, palladium, barium sulfate. It is Lindelar's catalyst. It is used to convert alkyne to alkene. It is not here. Then lithium aluminum hydride acidified water combination. Then aluminum diisobutyl aluminum hydride, diballoch water, third option. And lastly, sodium borohydride acidified water. We even in our textbook, esters are mentioned to be reduced to aldehyde using diisobutyl aluminum hydride, that is diballoch, then treating with the water. So without any confusion, 3 is the answer here. Okay, ester to aldehyde, aromatic ester to aromatic aldehyde in this case. Okay. The next question is question number 74. It is from organic chemistry, haloalkane and haloarine in second year, and it is based on SN1 SN2 mechanism. Okay, and here this is the only one assertion reason type question in this question paper. In the previous year question paper, it was not there, assertion reason type, only statement type were there. But here, one such question has been reintroduced. We will read the assertion and reason here. Assertion. Iodobutane. See, even in the question paper, the structure is given, not the name. One iodobutane undergoes SN2 faster than one chlorobutane. It is correct because in the textbook, it is clearly mentioned that for a given alkyl group, the substitution order is iodo greater than bromo greater than chloro, irrespective of the mechanism. Whether it is SN1 or SN2, it is the same. So in that case, this statement is correct because iodo react faster even in SN2 mechanism, where actually smaller group is preferred for SN2, less leaving type group is preferred in SN2. But here, due to this statement, experimentally verified statement, iodobenzene undergo faster reaction in SN2 mechanism. Reason, iodine is a better leaving group due to its large size. Reason is also correct. And assertion almost explains the reason, and so both assertion and reason are correct, and reason justifies the assertion is your option here. Okay, so the correct option here is 2. Okay, 2 is your answer. Okay, we'll proceed in the next set of questions. Okay, take care.